Hi, my dear friends. Welcome back to another Python tutorial class. Now, in this class, we shall go deeper into tuple, just like how we did in case of lists in our previous videos, where we dived deeper into the concepts of lists. Similarly, in case of tuple also, we shall try to do those same things. Now, first of all, we already know how to define a tuple. Like here, you have a variable tup to which this tuple is assigned. First bracket opening, and this is the closing bracket, which is your first bracket only, and these are the elements defined inside the tuple. Okay, 2, 5, 6, 5, 9, 11. So print tup, type tup, that shall give you the tup value, which is a tuple 2, 6, 5, 9, 11, and the class is tuple. The next is unlike arrays, tuples can have heterogeneous elements. Heterogeneous elements, that means that inside a tuple you can have various types of objects, various types of elements which belong to different types of data types. That's what we mean by heterogeneous elements. Whereas in case of arrays, which we shall come down later, whereas in case of arrays, they have homogeneous elements, that is objects which belong to the same data type, elements which belong to the same data type. Okay, so for example, here you have tup is equals to coding, this is a string value. Okay, then you have false, which is a boolean value. 11 integer, 3.7 float, 3 plus 4j is complex. Then here you have an inner tuple. Tuple inside a tuple is an inner tuple. 2 comma 4 comma 6, this is the inner tuple. Why? Because here you have this overall, all these things are enclosed within a tuple only. Like here you have the opening bracket, first bracket, and here you have the closing first bracket. Inside this, we are defining elements separated from each other by comma. That's what we mean by a tuple. So here inside this overall tuple, you have this inner tuple. Then next you have this list 5, 9, 10. Then you have this set 2, 4, 6. Then you have this dictionary 3 is to 300, comma 4 is to 400, keys to value. Okay, so this is overall a tuple consisting of heterogeneous elements. Like this is a string data type, this boolean data type, this integer data type, dot dot dot. Like this, you see, all the elements, they belong to different classes. They are different types of objects. They belong to different classes, belong to different data types. That's why we say that tuple can contain heterogeneous elements also. So if you run this, you get this. Okay. Now, another thing is duplicate items. We'll see. In case of set or frozen set, duplicate items are not allowed. We already know that, we have covered that. In case of set or frozen set, duplicate items are not allowed. Okay, but in case of tuple, duplicate items are definitely allowed. Like here, say for example, you have this variable tup, it is equals to, then inside this tup, that is tuple, sorry, you have these elements defined 2, 3, 2, 1, 6, 1, 6, 4, 3. Okay, and if you print this, then this tuple will be definitely printed. Wait a second. Now, yeah, so here you get this tuple where you have duplicate values, like 2 is repeated, then 1 is repeated, then 6 is repeated. Okay, 3 is repeated. So that's what we have as duplicate elements in case of a tuple. The next is, here you have a set. Set is equals to 2, 3, 2, 1, 6, 1, 6, 4, 3, like this you have. Now here you have duplicate elements, but when you print this set S1, then you won't get these duplicate values 1, 2, 3, 4, 6. That's what you get. Okay. Now another thing that I wanted to show was that what are the various types of operations that you can perform on a tuple, like length, concatenation, repetition, indexing, slicing. These things you can apply on a tuple. So length of a tuple. How to get the length of a tuple? Now for that you have to apply the alien function. For example, tup is equals to 3, 1, 2, 6, 7, 8, 9, 11, 4. This is a tuple, and you're trying to print tup tup, type tup, alien of tup. Okay, so this alien of tup will give you the length of the tuple, which is 9. That is, this tuple contains 9 elements. Now coming down later, concatenation of tuple. Concatenation of tuple. Wait a second. Concatenation of tuple. Concatenation of tuple means where it is the process of joining two tuples. Like in case of list concatenation, we have done it. how to concatenate lists. Similarly, we can concatenate tuples also in similar way using the plus operator. So joining two tuples gives you the concatenation process. Concatenation of tuple means you are joining two tuples with the help of the plus operator. That's what I've written here. Concatenation is done on a tuple using the plus operator. Now here you have a variable tup tup is equals to 1, 2, 3, 4. The next here you have tup1 is equals to xyz. Print tup id of tup, print tup1 id of tup1. So first of all here this tup tup, that is tuple, is printed and its memory id. The next tup1 is also printed xyz and its memory id. Now, in the next line, line number 5, I'm trying to do this tuple concatenation with the help of this plus operator. So, a new variable I've taken, tup2 is equals to tup plus tup1. So, both the tuples tup and tup1 will now be concatenated. So, that means these values x, y, z of tup1, they will be concatenated to this tuple tup after the value of 4. So a new tuple will be created here by the name of tup2, by the name of tup2, a new object that will be created at a new memory ID. So if you print tup2 comma ID of tup2, then this new tuple is we get. You see 1, 2, 3, 4. These are the values of tup comma xyz. Xyz are the values of tup1. So here we can see tup and tup1 have been concatenated and tup2 has been produced at this new memory ID. You see all these three memory IDs are different. Then next here you have, just try to run this. Yeah. You can only concatenate one tuple with another tuple. Just like in case of list, you can concatenate one list with another list only, nothing else. Otherwise, you will get type error. Similarly, in case of tuple concatenation also, if you want to do it, you have to do it with tuple only. A type error occurs when a tuple is concatenated with another type. Say for example, here you have a tuple 1, 2, 3, 4, 5, and here I'm trying to do what is tuple concatenation tup plus 100. Now a tuple can be concatenated with a tuple only. Tup tup is a tuple, but 100, is it a tuple? It is an integer data type, isn't it? So here I'm trying to concatenate a tuple with an integer, and if you run this you will get type error only. A tuple has to be concatenated with a tuple. Okay, next here you have in this next one, tup plus coding. Tup again is your tuple, and coding is nothing but your string data type. So here I'm trying to concatenate tuple with string, and that is not possible. I can concatenate a tuple with a tuple only. So if you run this cell, you will get type error. See, can only concatenate tuple to tuple, not str, that is string. Now in the next cell, tup plus. Here you have a tuple, that is tup plus, that is used for concatenation of tuple within brackets 50 comma 40. Now already we know that if you have a single value and after that value you give comma, that value will be treated as a tuple. And already we have two values here which are placed inside these brackets, first brackets, and these values are separated from each other by comma. So this entirely becomes a tuple. 50 comma 40 becomes a tuple, and tup is already a tuple. So with the help of this plus operator, I'm trying to accomplish tuple concatenation here. So if you run this cell, you will easily get these values. What is the value of tup? 1, 2, 3, 4, 5, and to this tuple, that is to this tup, these 50 comma 40 values, they also get appended here at the end. You see 50 comma 40. So 1, 2, 3, 4, 5 are the values of tup, and 50 comma 40 are the values of this particular tuple, second tuple. And here tuple concatenation was possible because I was concatenating here tup tuple with this tuple only. Tuple concatenation can be done when you concatenate a tuple with a tuple. Just try to run this value here. Now here tup, which is a tuple only, which we have seen already, plus is equals to. Now plus is equals to, if you remember, it belongs to the extend operation. Extend operation. Plus is equals to. It can be used as an extend operation for list. It can be used as an extend operation for tuple also. Okay. Now, internally, that's what it will do. Plus is equals to, if you give, internally, it will apply the extend operation. And if you remember, in case of extend operation, you need to pass an iterable as the argument. And then this extend operation it will basically append all the elements of the iterable one by one. If it has to append to the list, it will do to the list. Otherwise, if it has to append to the tuple, then it will append to the tuple only. So like here, 50 comma. Since I have given here a tuple, this is a value comma. So 50 comma, this will be treated as your tuple because I've given here a comma. If I don't give the comma and apply the extend operation, then you will get type error. Can only concatenate tuple to tuple, not integer. 50 is treated as an integer. Now, if I give comma here, then this value comma, that is 50 comma. So this 50 will be treated now as a tuple. And how many elements you have got inside this tuple? Only one element, that is 50. Okay, this was the first tuple, tup, and this now becomes my second tuple because here I have given 50 comma, value comma. So 50 will now be treated as a tuple only. Okay, and tuple is an iterable. So extend operation, what it will do here, first of all, you have to pass an iterable as the argument. So to this extend operation, I've already passed a tuple, okay, which is an iterable. And how many elements this iterable tuple has got? It has got only one element, one and only element, that is 50. And extend operation, what it does, it will basically append all the elements of the iterable one by one. So it will first of all append this value of 50 to where? To this tup, which is a tuple only. So extend operation, what it will do is that it will basically append this value of 50 to this tuple tup, where? At the end of tup. And it was extend operation is able to append only one element here because overall in this tuple you have only one value, that is 50. This is overall a tuple only. This 50 is now treated as a tuple due to the comma. And overall in this tuple you have got only one element. So only this one element will be appended at the end of tup, which is a tuple. And courtesy to whom? Courtesy to this extend operation, plus is equals to. So if you give this tup, you see 1, 2, 3, 4, 5. Already I've got a, this is a tuple only that I get. This is a tuple only that I get, and which is nothing but a tup. Tup is a tuple. Now inside tup already we had these values 1, 2, 3, 4, 5. Now a new value has been appended to this tup, which is your 50. Previously, that was not the case. If here you see, with the help of plus operator, when I was trying to do the tuple concatenation, then a new tuple got created where you had these values 1, 2, 3, 4, 5, 50, comma 40. And when in the next cell, when I tried to see the value of tup, so I just simply wrote tup and ran the cell, and I got the original values of tup 1, 2, 3, 4, 5. So here a new tuple got created. These values of 50, 40 were never appended to tup. Rather, a new tuple got created. So that's why the tup value remain unchanged. But here, this extend operation, it will basically append this value of 50 to this tuple tup. This extend operation plus equals to will append this value of 50 at the end of the tup, where tup is a tuple. So that's why you see now tup values have been modified. Previously it was only 1, 2, 3, 4, 5. Now along with it, at the end of tup you have this value of 50 also. Okay. Then next, repetition of tuple. Repetition, already we know how it works with the help of asterisk operator. The repetition operation on a tuple is carried out using the asterisk operator. Okay, so continuously, if you want to try to repeat out couple of outputs, then for that you have to use the asterisk operator. So for example, here you have tup, which is a tuple, is equals to 1, 2, 3, 4. Print tup into 3. What will happen? The values of this tuple will be repeated thrice overall. First of all, here you have 1, 2, 3, 4. Then again here 1, 2, 3, 4, and again here 1, 2, 3, 4. So three times the values are repeated overall. So this is what is meant by repetition of tuple with the help of asterisk operator. Just try to run this cell. Yeah. Then here you have tup is equals to, here you have string value, that is coding, then boolean value false, then integer 12, float 3.73 plus 4j, that is complex, 2 comma 4 comma 6, there is a tuple, 5 7 8, it's a list. This one is a list. 2 comma 4 comma 6 is a set. Okay, so this tuple contains heterogeneous elements. Get the first element. Get the first element means you have to get the string value coding. So there are various ways through which we can get these values. This is indexing, how to apply the index in case of tuple. Same, just same, whatever we did in case of list, same The in same way you can access the values via indexing here also in case of tuple. So print then tup 0. Tup 0 means the if I'm going via the positive indexing, that is from left to right, then what are the index positions? Here it belongs to the index position 0, this belongs to index position 1, this belongs to index position 2, index position 3, index position 4, index position 5, index position 6, index position 7. So tup 0 will it will do what? The zeroth index position of tup will be attacked, and whatever value is there, that will be printed. That is coding. You see, coding is printed. Alternate way, print tup, then within the square brackets what I'm giving here is, first of all, print function, then inside print I'm passing tup, and for accessing the index I have to give the square bracket. If you remember, square bracket opening, square bracket closing, inside this you can pass your index in whatever manner you want to, like directly number or via the help of alien function. So minus alien of tup, minus ln of tup. What is the length of this tup here? How many elements it has got? 8 elements. So ln of tup will give you 8. And to this ln, what I've given? Minus. So here it will be minus 8. It will be minus 8. Minus ln of tup will be nothing but minus 8. So overall, this will become tup minus 8. That's where it becomes tup minus 8. What do we have at tup minus 8? Minus means negative indexing going from right to left. So this is the first index position of this set, which will be at, at minus 1. Then here you have this list, index position is minus 2 going from right to left. Okay, then this index position of this inner tuple, it will be minus 3. Index position of this complex, it will be minus 4. Index position of this one will be minus 5. Then index position of this integer 12 will be minus 6, isn't it? Then index position of this one will be minus 7. Index position of this one will be minus 8. Coding. So ultimately you get coding again here, you see here. And directly if you want to use the number, then print tup, then inside tup you pass minus 8. So same thing only, at minus 8 we have this at minus 8th index position of this tuple tup, we have the string value coding that will be your printed. Okay, now get the last value, get the last value. So last value means this one. If you are going from right to left, negative indexing, then this set, it lies at what index position? It lies at minus 1th index position. So print tup within square brackets you pass minus 1. So at minus 1th index position of tup you have this set, and this set will be printed. You see 2 4 6. And if you want to go via the positive indexing, that is from left to right, then print tup 7. You have to pass 7 inside the square brackets of tup. So seventh index position of tup will be taken into consideration. So it will start from left to right, that is positive indexing. Index position is 0, 1, 2, 3, 4, 5, 6, 7. At seventh index position you have this set. This set is printed here. And if you want to apply the alien function, then already, like I have already told you that this is the universal formula. Whenever, like inside any kind of an iterable or data structure, you can have huge number of elements. So in this way, if you want to access the first element, this is what you have to do using the alien function. All right, it will always grab the first value of any iterable going from left to right, and going from right to left, going from right to left. It will always grab the last element. Like here, it was coding the first value that we get from going from left to right, and going from right to left. This becomes the last value. Now, similarly, in order to get the last value, last value means by default, conventionally speaking, going from left to right. Okay. So get the last value means only this set only we are talking about 2 4 6, conventionally going from left to right. Print tup, then inside the square brackets of tup, what do we pass? We pass alien of tup minus 1. Alien of tup minus 1. Now what will be alien of tup? Alien of tup is nothing but your 8, and here you have alien of tup minus 1. That means 8 minus 1, that is equals to 7. So overall this will be tup 7. And this seventh index position of tup, you have the set 246, which will be printed. This is universal formula. Okay, you have to remember this for our next upcoming videos because we shall be using it pretty frequently. So just try to run this cell. Yeah. Then next here you have slicing of tuple. Slicing also we have previously seen. Okay. So like here you have the previous values only coding false 12, 3.7, 3 plus 4, 2, 4, 6, 5, 7, 8, 2, 4, 6. Print tup0, it shall give you the first value coding. Then print tup 1 is to 3 is to 1. So what is the start value here? Start value of index position is 1. Okay. What is the stop value? Stop value is 3. Stop value is always excluded. So Python will go just before the stop value. That is if we go up to 2. In what step size? In the step size of 1. Okay, so overall it will be first of all 1th index position that will be conquered, then 1 plus 1 is equals to 2, so 2th index position. So at first 1th index position will be attacked, then 1 plus 1 to the step size which is fixed at 1. 1 plus 1 is equals to 2, so second index position will also be attacked. Attack means from where the values will be grabbed. So at 1th index position, what value we have? False, we get false. Then at second index position, that 2th index position. At 2th index position, what value we have? 12. So false, comma 12 we get here. Okay. Then print tup 0 is to 2 is to 1. 0 is to 2 is to 1. How will it go? 0 is to 0 will be the start index, 2 is the stop value, and that will be excluded. So Python will go just before 2, which is nothing but your 1. And what is the step size here? Step size is 1. So at first, it will start with the 0th index position, grab the element and print it. Then plus 1, because the step size here is 1. So 0 plus 1 is equals to 1. Next, after the 0th index position, 1th index position will be also attacked. And from these two index positions, values will be printed. So at 0th index position, what do we have? Coding. And at 1th index position, what do we have? False. So in the next line, you get this tuple coding comma false. Okay. The next is print tup 1 is to 5 is to minus 1. Now here, what do we get? Here we get empty brackets. Why? Because here you see start value is positive, stop value is positive, but what is the step size I'm giving? Negative. That's why it cannot proceed only. Like from positive to positive, if you are going, then you need to give positive positive step size. But here the step size I have mentioned as negative. Okay. So 1 minus 1 will be 0, 0 minus 1 will be minus 1. That's not how is going to work, because here these indexes that I have provided are all positive. So the step size that I have to give here must be also positive. Okay, not minus 1. So that's why you get empty brackets. Then print tup minus 1 is to ln of tup minus 1 is to minus 1. Here what do we get? Here also we get empty brackets. Why? Because first of all, you see, start index is negative, stop index is positive, isn't it? Ln of tup minus 1 will be what? 8 minus 1, that is 7. How many elements here we have? 8. So 8 minus 1 is 7. So it is like minus 1 is to 7 is to minus 1. Python cannot grab it only because here the start index has been negative and the stop index has been positive. Okay, this is the start index minus 1, stop index positive. So minus 1 is negative, which is the start index, and ln of tup minus 1 is the stop index, which is positive. Okay, this is negative start index, and here you have positive stop index. And what is the steps as I'm giving? Minus. So overall it gets confused like how to proceed, how to move. Okay, so that's why here you get empty brackets. Then again, minus 3 is to ln of tup minus 1 is to minus 1. You see again the same issue. Start index, it is your negative. Stop index, it is your positive. And what is the step size? Negative. So that's why it cannot proceed only, and hence you get these empty brackets. Okay. Now next is print tup, this one, line number 8. This one. Okay. Here what's happening is that now the situation becomes slightly more, what should I say, easier. You will understand. Alien of tup minus 1. This is a start index. Okay. What will be this? This will be your 7. Alien of tup means total how many elements of tup? 8. So alien of tup will be 8. 8 minus 1 is 7. 7 is 2. Now minus 3 is what? It is the stop index. Minus 3 is the stop index. This will be excluded. So Python can go just before the stop index. Just before minus 3, what do we have? Minus 2. So it will go up to minus 2 is to minus 1 is to minus 1. Okay. So it will start with seventh index position. Python will start with seventh index position. It will go up to minus 2. And now you see the seventh index position. At seventh index position of top, what do we have? We have this set. Okay, this is at seventh index position. What do we have? We have at seventh index position of tup. You have this set 246. Now this also belongs to minus 1th index position, and this list belongs to the minus 2th index position. So Python here has to go reverse, like it has to start from right to left. First it will grab this particular element, that is this set element 246. Then it will grab this list element, that is 578. So it will start its journey from here. Then in the step of minus 1, it will proceed further from right to left and come to here. So this is the minus 1th index position. This is the minus 2th index position. So actually we are mentioning that it will start from 7th index position and will go from right to left and will grab up this minus 2th index position in the steps of minus 1. Now minus 1 makes logic because now we are going in the reverse direction from right to left. So that's why we get here overall this tuple 2, 4, 6, 5, 7, 8. Okay, it starts from right, goes towards left in the steps of minus 1. Let it be 7th index position. From 7th index position, you're going to the minus 2th index position. This is definitely at minus 2th index position. This is not only at minus 1th index position, alternatively at 7th index position also. So from right to left, we are going in the reverse direction in the steps of minus 1. So it is at 7th index position, and then it has to go to the minus 2th index position in the steps of minus 1. Minus 1 makes sense when you're going in the reverse direction from right to left. So now you see, that's why here there is no issue. You directly get a positive output 2, 4, 6, 5, 7, 8. Okay. So the start index, this is how it's going to operate correctly when the start index is positive and the stop index is negative, and you give a negative step size. That is, Python will go from right to left, and when Python will go for right to left, it has to make sense. It has to make sense. Okay, going from right to left in the reverse direction, negative direction means in the steps of minus 1. And here you can give the stop index as negative and the start index as positive and the stop index as negative. Okay, then print up is to minus 1. Overall, what will happen? The entire tuple will be printed in the reverse order, that is from right to left entirely. 246, there is the set, then 578, there is the list, then 246, there is the tuple, 3 plus 4j complex, dot 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 up to coding. Here you see it starts with 246, 578, 246, 3 plus 4j goes up to coding. Okay. Python, as we have already seen this, that the start index and stop index, no need to mention. Python will automatically grab that. Python will automatically grab that. So just for your recap, when you're giving this start index, it can be the start index. You can give it as positive. Ln of tup minus 1 is 7, which is positive, and this stop index you can give it as negative. This stop index you can give it as negative, and that means only you're going from right to left in the reverse direction. So in that scenario, you can give minus 1 the step size. Python will understand that it has to go in the reverse direction from right to left, provided that you have given the stop index as negative and the start index as positive. Okay. Now here I didn't mention any start stop, and Python automatically understood and printed the entire tuple in the reverse order. And the next print up is 6 is to minus 1. So what will happen here is the sixth index position is the start index position. 6 is what? 6 is the start index. That's what I've mentioned here. Stop index, have I mentioned it here? Again, 6 is the start index. I have mentioned it here explicitly. So Python will start its journey from the sixth index position of tup. What about this? What about this stop index? I have not given any stop index here. So Python will automatically figure out the stop index. and is to minus 1. Here this is the step size. So Python will understand it has to go in the reverse order from right to left. So stop index, you have provided nothing. Python will automatically figure out what is the stop index. Okay. If you do not mention anything, the last element will be grabbed up by Python by default. Okay. So 6 is to minus 1. Start index position. Start index position of tup top is 6. And here we have 6. At 6th index position, you have this list. At 6th index position, you have this list 5, 7, 8. Now Python will start its journey from the 6th index position, and it will go in which direction? It will go in the negative direction, that is from right to left, starting from the 6th index position till up to the last element. So 5, 7, 8, then this tuple, then this complex, then this float, then this integer, then this boolean, and then this string. So starting from 5, 7, 8, you see this entire tuple, this tuple is printed, but tuple is printed from where to where? Starting from 5, 7, 8, because we mentioned it to Python that the start index position has to be 6. At sixth index position, you have this list 5, 7, 8. Then gradually it went from right to left in the negative direction. So 5, 7, 8, then 2, 4, 6, 3 plus 4, 0, 3.7, 12 false coding till the last element. Okay. And also alternately, you can give print tup. Then inside tup, you are passing 6, which is the start index position. And now explicitly we are mentioning the stop index position. Okay, like here we didn't mention any stop index position, we just explicitly mentioned the start index position. Now here we are mentioning the start index position explicitly, and then we are also mentioning the stop index position explicitly. Minus ln of tup minus 1, this is again the universal formula by default which you have to grab up. Okay, so minus ln of tup minus 1. What will this be? It will be nothing but is equals to minus ln of tup is how much? 8. 8 minus 1. So minus 8 minus 1 is equals to minus 9. So stop index position will be minus 9. Stop index position will be minus 9, and Python will exclude this. Stop index position is minus 9, which will be excluded. So Python will go just before the stop index. That is just before minus 9. What do we have? We have minus 8. So Python will go up to minus 8th index position, because minus 9 is the stop index position that will be excluded. So Python will go just before it, just before minus 9. What do we have? Minus 8. So it will start its journey from 6th index position, and then will go up to minus 8th index position. That is, it will start its journey from here, then it will basic Python will start its journey from here, 6th index position of tup. Then it will go in the reverse direction, that is from right to left, because here the step size is minus 1. So it will go in the negative direction, in the opposite direction, that is from right to left. It will start its journey from the 6th index position, grabbing up this list till up to the last element. Till up to the last element. What is this last element? Last element is coding. Why? Because Python will go here up to what index position? Minus 8. And at minus 8th index position, at minus 8th index position, what do we have? We have the string value, that is coding. At minus 8th index position of top, what do we have? We have this string value, which is coding. Okay, so starting from 6th index position, that is grabbing up this list, Python will go from right to left, because here the step size is minus 1. So means it will go in the reverse direction, negative direction. So 5, 7, 8, then 2, 4, 6, 3 plus 4, 0, 3.7, 12 false, up to coding. Why? Because Python has been given here. Python has figured out that the stop index position actually where till up to it has to go is nothing but minus 8. And at minus 8 index position, you have this string value coding. So you can see 5, 7, 8, 2, 4, 6, 3 plus 4, 0, 3.7, 12 false coding. Okay. Then already we know this that tuple is immutable unlike list. Immutable means once defined it cannot be modified. List is mutable. Once defined can be modified also. There is no memory, no new object will be created, no new memory ID will be created. Whatever object at a particular memory ID we had, that got updated. But not the case. That is what you mean by mutability. Hence, we saw that list is mutable. But in case of tuple, that's not the case, because tuple is immutable. So what it means? Immutability of tuple. Once the elements are defined, we are unable to change them. This is with respect to tuple. Once the elements are defined, we are unable to change them. It is not possible to assign objects. It is not possible to assign objects. That is, what should I say? Assignment. Assignment of new elements not possible once the tuple has been defined. The addresses are different before and after the change if we change the values somehow. Now there are some bypass ways by which we can modify the tuple, but the original tuple won't be modified. Instead, we will get a new tuple, a new object, which will be created at a new memory ID. That's what it means. Addresses are different before and after the change if we change the values somehow, some way. Now see, for example, here again this same tuple we have taken, tup is equals to all these heterogeneous elements. Now print tup3. Print tup3. That means whatever is there at the third index position of tup, that will be printed. So 0, 1, 2, 3. At third index position of tup, you have this 3.7 that is printed. Now I am trying to assign a new value. I'm trying to assign a new value at this third index position of tup. So this 3.7, which is there at the third index position, that I'm trying to replace by this value of 35. We have already seen assignment, like here you have to give variable, then inside the square bracket you give the index is equals to a new value. In case of list, this works, but not in case of tuple. If you try to run this, you see you get error. Tuple object does not support item assignment. Okay. Now similarly, if you come down, tup is equals to coding false 12, all these heterogeneous elements that we have previously seen. Here you have list L is equals to 1 2 3 4 5. Print tup comma id of tup. So first of all, this tuple will be printed, entire tuple that we created, and its memory id will be also created. That is wherever wherever we created this tuple, at whatever memory id we created this tuple, that particular memory id is printed here. Now what I'm trying to do here is for I in L. For I in L. So for loop will start. So for loop will start where? For loop will start over this list. Okay, so for I in L, I will first iterate over 1, then I will iterate over to 2, then I will go to 3, then I will be 4, then I will be 5. So for I in L, first value is 1. What is the value of I right now? I has started its for loop journey in this list L. For I in L, I has first iterated over to this value, that is 1. I is 1 right now. Okay. So tup plus equals to. Already this tuple tup has been defined here in line number 1. Now plus is equals to, we know what happens here, extend operation, and extend operation will nothing do, but it will do concatenation only, that is append only, and for that you need a tuple only. That is, if you want to concatenate with the help of extend operation to a tuple, then the other iterable should be also a tuple only. Okay. So for that I have given here I comma, because what is the value of I right now? The value of I right now is nothing but your 1. So it will be 1 comma. So it will be value comma. Value comma, that means 1 comma. So overall this 1 will now be treated as a tuple. Now extend operation will be able to do the tuple concatenation, because even with extend operation also, like with the help of plus equals to operator also, we try to do the tuple concatenation, and for that both data types should be tuple. The first data type, there is a first object should be a tuple, and the second data type, there is a second object should be also a tuple. Now here this 1 comma makes sure that this 1 becomes a tuple. Okay, so extend operation will do what? It will append this value of 1 at the end of this tuple. Okay, and in the next line, print tup comma id of tup. You see, coding false 12, 3.7, 6 plus 4, 0, 2, 4, 6, 5, 2, 6, 2, 4, 6. Up to this, whatever the original values of tuple were there, they're all printed. Lastly, at the end of this tuple, you see the value of 1 has been appended. And ID of tup does what? ID of tup gives the memory ID. ID of tup gives the memory ID of this tuple. Now what happens here is, you see, this memory ID is different. This memory ID is basically different from this memory ID. That means a new tuple, a new object has been created at this particular memory ID. And here you're getting this value, that is from coding dot 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 till up to 1. In case of list, that does not happen. In case of list, it does not happen. Why? Because we already have seen in our previous classes that in case of list concatenation, when you try to do it with the plus operator, then a new list will be created. A new object will be created at new memory ID. But if you try to do list concatenation with the help of extend operator, that is dot extend or plus equals to, then no new object, no new list is created, hence no new memory ID will be also there. Whatever list or object we had at a particular memory ID, there only the update happens. But in case of tuple, we already know that it is immutable. Once defined, cannot be modified. However, if you are able to do some modification into it, then a new tuple or a new object will be created at a new memory ID. That's why we say tuple is immutable. That is, even if it is you are able to modify it, still at that same memory ID, whatever the new object was, whatever original object was, or whatever original tuple was, that won't be modified. Okay, so here extend operation in case of list will give you the same memory ID because the same object, the same list you get. But in case of tuple, if you want to do the tuple concatenation with the help of extend operator, then here you will get a new tuple created at a new memory ID, not the original tuple at the original memory ID. That remains the same. That doesn't get modified. Rather, a new tuple will be created at a new memory ID, even with the help of extend operator. So definitely memory ID changes, object changes. That's why tuple is immutable. If the memory ID doesn't change, object doesn't change, the same memory ID, their modification happens. In the same object, modification happens. Then it is mutable, like list, but not in case of tuple. Then as you can see, for loop continues to run, and the rest of the values of the list, they also get appended one by one at the end of the tuple, and every time we get a new tuple, that is a new object at a new memory ID. Like here you see the control goes back from the print statement directly to the for statement again, that is for I in L. So in that scenario, what happens? I iterates over to the next value. I iterates over to the next value, that is 2. Okay, I iterates over for I and L, it runs again, and I iterates over to the next value 2. So tup plus is equals to I comma. So this will be now 2 comma. And extend operator will do what? It will append this value of 2 at the end of the tuple. Okay, so coding false, all these values you get dot 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 up to 1, then comma 2, comma 2. So through the naked eye, it may be perceived that the tuple is getting modified, but not in reality. A new tuple is created, a new object is created at a new memory ID. Here you see the memory ID is again different from the previous one. Definitely from the first one, and definitely different from the second one also. This third memory ID is different from the first one as well as from the second one. So means a new tuple has been created at a new memory ID. Then again, I iterates over to the next value, that is 3. So you will get coding false, the original values of the tuple, comma 1, comma 2, comma 3. Okay. So concatenation of tuple with the help of extend operation is happening, but tuple is still immutable because the original tuple was this one created at this memory ID. Here at this memory ID, no changes in the object. Each time a new object gets created at a new memory ID. So you see again a new memory ID you get, that is a new tuple has been created here. Okay. Then again the for loop continues to run, and I iterates over to the next value, that is 4. I iterates over to the next value, that is 4. And again you see the original values of tuple from coding dot 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 up to 246, then 1 2 3 up to 1 2 3 already we saw in the previous iteration of the loop. In the current iteration of the loop, the value of 4 also gets appended at the end of the tuple thanks to this extend operator. Okay. Then again, for loop has not yet ended. So the once this print statement has been executed, the control will jump from this line number 6 to line number 4. The for loop runs again where I moves to the next value, that is I becomes 5. So now again tuple concatenation will happen with the help of extend operation. Rather, a tuple extend operation will happen, and coding false 12 dot 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 1 2 3 4. Already these values were there. Now this is the final value of the list, that is 5, which gets appended at the end of the tuple. Here you see after 1 2 3 4 5, the final value of the list, that is 5, gets appended at the end of the tuple tup. But here a new tuple has been created with all these values. A new tuple has been created with all these values or all these elements, and that means a new object has been created, and that has been created again at a new memory ID. So you see, all these memory IDs, these are different from each other. First one, second one, third, fourth, fifth, sixth. All these memory IDs are unique because each time this extend operation comes into the scenario to do tuple concatenation. I shouldn't say tuple concatenation, rather tuple extend. You should say, okay. Just for the naked logic, I can say that concatenation, but in reality, it is like the extend operation only. Here, every time you're getting a new object at a new memory ID. So just okay. Then coming down to the next one, coming down to the next one, yeah. Tup is equals to here again the same elements you have for this tuple. Now tup minus 2 minus 1. What will this do? This double indexing. If you remember, double indexing we did in case of list. First of all, minus 2. At minus 2th index position, what do we have? We have this list. At minus 1th index position, what do we have? We have this set. At minus 2th index position, what do we have? This list. Then another square bracket and minus 1. So what will happen? First of all, the target will be locked. The target will be locked at minus 2th index position of tup. So particularly speaking, this list inside the tuple has been locked. This list inside this tuple has been locked. Okay. Now minus 1. This minus 1 will do what? It will now hover, or it will rotate, or it will basically simply go through this list only. Okay. Now at minus 1th index position, at minus 1th index position of this list only, I'm just talking about this list. At minus 1th index position of this list, what do we have? We have this value of 6. Okay. So what I'm trying to do here is tup, which is overall a tuple, minus 2 minus 1. Minus 2 means first of all this list is attacked, and then because that's where it lies at minus 6 with index position of tup. Then minus 1. Minus 1 means now we are going inside this list. First of all, minus 2. Minus 2 means at minus 2th index position of this tuple, you have this list. Now another square bracket minus 1. That means another index position. So that means now we are going inside this list. Going inside this list means minus 1. Minus 1 means here the value of 6. Like this is minus 1. It lies at minus 2. This lies at minus 3 for this list only, coming from right to left, negative indexing. And if you go from left to right, positive indexing, then this lies at 0th index position. Then this 2, it lies at 1th index position, and this lies at 2th index position. Anyways, here I've given minus 1. That means this list will be iterated in the negative direction. That is via negative indexing. Okay. So at minus 1th index position of this list, what value we have? We have 6. Now, tup minus 2 minus 1 is equals to 200. In case of list, item assignment is possible. In case of list, modification is possible. That is, whatever value was defined, that can be changed also. So now 200 will be inserted in place of 6. 200 will be inserted inside this list in place of 6. So if you do this, print tup comma id of tup, you see overall what do we get? You get this tuple. True coding false 12 3.76 plus 4j 2 comma 4 comma 6. Now focusing just on the list which is enclosed within the tuple, here you see 5 comma 2 comma 200, not 5 comma 2 comma 6. Here we had original 526, but here it now becomes 5 comma 2 comma 200. Okay. And this is the memory ID of the tuple. So here you can see that basically we have done the modification inside the list of a tuple. Now list modification is allowed. List modification is allowed means no new object, no new memory ID at that same memory ID, at that same object only modification is possible. Modification can be done. Now tup minus 2 dot append tup minus 2. Tup minus 2 means what? Minus 2th index position of this tuple, that is 5 comma 2 comma 200. Now it becomes, now it is 5 comma 2 comma 200. This list, it lies at minus 2th index position of tuple. Dot append. Append operation we have already seen in our list classes. Append operation we have already seen in our list classes. Append, it appends the value at the end of the list, and it appends one value at a time. And inside the append function, what I'm passing this iterable. What is this iterable? It is nothing but your tuple. 2 comma 4 comma 6. So this tuple 2 comma 4 comma 6 will be appended inside the tuple after the minus 2th index position, after the value which lies at minus 2th index position of the tuple tup. So let us see. That means after 5 comma 2 comma 200, this tuple 2 comma 4 comma 6 will be appended inside the tuple only. Okay. So print tup, comma id of tup. Okay. So what happens here is coding false 12 3.7 6 plus 4j 2 comma 4 comma 6 comma. Now you see inside this list append has successfully happened. That is inside this list 5 comma 2 comma 200 was already there. Now I was trying to apply this append method inside this list, and what iterable I was passing? This tuple 2 comma 4 comma 6. So this iterable, that is this tuple, will be appended to this list. What list? 5 comma 2 comma 200. Now we see 5 comma 2 comma 200 is already there. After that, this tuple, that is this iterable that we passed, has been successfully appended at the end of the list. At the end of the list, you see this is the list. So again, list modification we have done. Again, list modification overall we have done. Tuple is overall a container. Inside this container you have list is also a container. Okay, now inside the inner container, that is inside the list, you are doing some changes, and we know that uh, inside a list when you do changes, memory id does not change. Okay, and overall that is allowed. In case of list, it is allowed. So inside the tuple directly we are not doing it, but indirectly we are doing modification inside the list of the tuple. So in that scenario, no new tuple, no new object, no new memory id will be created. At that same object, at that same memory id only, we will get our tuple values. So you see, comma 2 comma 4 comma 6, this is the set, and then here you have the memory id. Like here I've given print tup, comma id of tup, print tup, comma id of tup. So the entire tuple is printed here, and here you see the memory id 263191228568. This is the same as this memory id. This is the same as this memory id, because inside the tuple, directly to the tuple we have not done. That is inside the original container, we have not done any modification. If we would have done any modification, then we would have shifted to a new container at a new memory id with definitely the updated values. But inside this container created at a memory id, directly we are not placing anything. Rather, inside this container you have an inner container which is the list, and there inside that inner container we are doing modifications, where in case of list, when you do modifications, memory id does not change in case of the list, and the tuple also doesn't get affected overall. So that's why here the original tuple remains. The original tuple remains, and inside this original tuple you can see that this updated list we have got. Initially the list was updated from 526 to 5 to 2 5 comma 2 comma 200. Then further, with the help of append method, we again updated our list, and it became 5 comma 2 comma 200 comma 2 comma 4 comma 6. Okay, and overall this list updation inside the tuple has happened, and hence no new tuple has been created. Whatever the original tuple was created at this same memory, created at this memory id, we get this same tuple only and this same memory id only, with only difference being that inside the tuple we have this list, and that list has been modified successfully. Okay, so this one thing you can remember. So here no new tuple, no new memory, no new tuple has been created, no new object has been created. The same tuple only we get, and that same memory ID only we get. Okay. Then ways to generate a tuple. Already we have seen this. Way one, how to create a tuple. You give this opening bracket, first one, then this closing bracket, second one. Inside this, you pass these values 1, 2, 3, 4, false coding 11 plus 22j. Print tup, comma type of tup. Definitely it belongs to the class tuple. Type of tup will give you the class, and these tuple values we get. This is way one to create a tuple. Another way two is str1 is equals to world class. This is a string value. This is a string. Str1 is now a string iterable. Print str1 comma type of str1. So this string value you get world class. It belongs to the class string. Now tup is equals to tuple. Inside the tuple, you pass your iterable, that is str1. So what it will do is that each and every element or each and every character of the string shall be taken into consideration inside a tuple as a separate element. Okay, each and every character of the string str1 will be taken into consideration inside a tuple as a separate element. So first of all, tup is equals to tuple str1. Here tuple is used for typecasting. It will be used to typecast this entire thing into a tuple. Then print tup comma type of tup. So the tuple, this tup will be printed. This tup is nothing but your tuple, first opening bracket and first closing bracket. Inside this you see you have w, world class. How many? Here you have so many characters: 1, 2, 3, 4, 5. Space is also character: 6, 7, 8, 9, 10, 11. 11 characters you have got. So each and every character will be taken as a separate element inside this tuple. So first you have w, comma, then you have o, then you have r, then you have l separately, then you have d separately, then you have space character. Okay, then you have c, l, a, s, s. So just run this. Then next you have L is equals to, this is a list, print L comma type L. Now with the help of this tuple method, I will be inside this tuple method, I am passing this L variable, which is nothing but your list. So this list will be now typecasted into a tuple thanks to this method, tuple method, and the entire thing will be assigned to this variable tup, which will be ultimately a tuple. So print tup comma tup. First of all, you see list has been printed. Now this list has been typecasted into this tuple. Here you see all the elements of the list have been now taken inside the tuple. The list has been typecasted into tuple. 1, 2, 3, 4, 5, 6 class tuple. Same elements only, now you get a tuple. Okay, so this tuple will typecast the list into a tuple. So just run this. Next, here you have emp1 is equals to, then here you have the opening curly brace and here you have the closing curly brace. And now what do we have? Emp is to John. Emp underscore age is to 32. Emp underscore salary is to 72,000. Place is to Delhi. So this means it is a dictionary because of this double colon sign, is to sign. Here this is the key and this is the value. John. EMP is the key, John is the value. Then again, here EMP underscore age, it is the comma. EMP underscore age, it is the key, and 32 is the value. Then EMP underscore salary, it is the key, 72,000 is the value. Place is the key, daily is the corresponding value. So how many elements you have got? Each keys to value pair, each keys to value pair inside a dictionary is an element. So this is the first keys to value pair, first element. This is the second keys to value pair, second element. This is the third keys to value pair, third element. Okay, and then here you have the fourth keys to value pair, which is the fourth element. So if you do print emp1 comma type emp1, you get this entire dictionary, which is definitely it is a dictionary, so belongs to the class dict. Now tup is equals to tuple emp1. Now we are trying to typecast this dictionary into a tuple with the help of tuple method. So ultimately, dictionary will be typecasted into a tuple thanks to the tuple method, and entire thing will be assigned to this variable tup. So print tup, comma type tup, comma id of tup. If you do, you see here you get the list, and here you get the tuple. Here you get the tuple, and inside the tuple, what do we have? We have only the keys. Inside the tuple, what do we have? We have only the keys. So these are tuple only. This is the first bracket opening. This is the second bracket. This is the first bracket closing, and that means it is a tuple where inside this you have the values separated from each other by commas. Okay. So inside this tuple, you have only the keys: emp underscore age, emp underscore salary, place. You see, emp underscore age, emp underscore salary, place. Only the keys. So class tuple, definitely typecasting has been done with the help of tuple method. This is the memory ID of tup. Now here we didn't get the values. Here we didn't get the values. So if you pass a dictionary, if you pass a dictionary as an iterable inside the tuple method, then this tuple method will do typecasting. It will typecast the dictionary into a tuple. But by default, inside that tuple you will have only the keys of the dictionary, not the values. Okay, now to get the values of the dictionary, you will have to explicitly mention values. So how to do it? Tup is equals to tuple. Then inside the tuple method, what you're doing is emp1 dot values. Emp1 dot values. So dot values, already we have seen this, the application of dot values. In case of list also, we came across the same scenario. Only that was a list. This time it is a tuple. So again, tuple method will typecast this dictionary emp1. Tuple method will typecast this dictionary into a tuple. Okay, and what will be the elements of that tuple? The elements of the tuple will only be the values of the dictionary. So to achieve those, we have to use the dot operator and then access this method, values method. And in case of method, you have to give these brackets, first brackets, opening and closing ones. So emp1 dot values, emp1 dot values inside tuple will do what? Now this will typecast. The tuple method will typecast this dictionary into a tuple consisting of values of the dictionary. So when you print tup type tup id of tup, then here you get a tuple. Here you get a tuple, and definitely we use the tuple method for typecasting into tuple, so we will get tuple only. Inside this tuple you have John 32, 72,000, Delhi. These are only the values of the dictionary, not the keys. Just the values of the dictionary have been taken into consideration. Again, these are arbitrary, random and fictional names and values that I've taken here just for your educational purposes. Okay, and this is the memory id. Okay, now, after that, tup is equals to tuple. Tup is equals to tuple. Inside the tuple, I pass emp1 dot items. This is a new method. This is again a new method that you can apply over a dictionary. Dot items. Again, to access a method inside a tuple, we need to use the dot operator. So items is a method which we have not seen so far. Now we shall see. Items will do what? Items will, it is applicable first of all to a dictionary. Okay, this will return you a dict underscore items object. This will return to you a dict underscore items object. This items. Whenever you apply this dot items over a dictionary, it will return you a dict underscore items object, and that will be what? It will be nothing but list of tuples. It will be nothing but list of tuples, because you see inside the dict underscore items you have this square bracket opening, and here you have the square bracket closing. So definitely a list. Inside this list you have tuples, set of tuples. You see, this is the first tuple, this is the first tuple, then this is the second tuple, then this is the third tuple, and then this one will be fourth tuple. Okay, this one will be fourth tuple. So that's why this dot items, when you apply it on over a dictionary, this dot items, when you apply over a dictionary, it will return you dict underscore items. It will return you just first of all, let me run this once. Yeah, this will return you the dict underscore items object, and inside this dict underscore items object you will have a list of tuples. Why list of tuples? Because first of all you have a first of all you will have first of all you will have overall a list, opening square bracket, closing square bracket. Inside this list you will have these sets of tuples. That's why this dict underscore items will be nothing but your list of tuples. And what will happen here is inside each tuple you will have two elements. Inside each tuple you will have two elements. First element will be the key. Second element will be the value. Like here, see for example, emp comma John. This is the key, and this is the corresponding value. So emp is the key and John is the value. So this is the first tuple. Inside this first tuple you have two elements. First element is the key, that is emp, comma second element is the value, which is John. Okay, then this is the second tuple. Inside this tuple also we will have two elements. First element will be the key and second element will be the value. You see, this should be the second tuple inside the list. The inside the tuple you will have two elements. First element will be the key that is emp underscore age. Second element will be the value, that is 32, and that's what we get here. Okay. Then the third tuple, again inside this third tuple you will have two elements. First element will be the key, second element will be the value. So this is the first element, which is the key, emp underscore salary, and comma, the second element will be the value. So what is the corresponding value here? What is the corresponding value here? It is 72,000. Okay. Then next, comma, the fourth tuple. Inside this fourth tuple, what do we have? You will have two elements. First element will be the key, second element will be the value. Okay. So what is the first element? Key. What is the key here? Place, comma, what is the value? It is this Delhi. So you see, key comma value, place comma Delhi, key comma value, place comma Delhi. Okay. Now, at first I explained you directly this one. Print emp1 dot items. Print emp1 dot items. When you do, then you get this dict underscore items, which will be nothing but your list of tuples. And inside each tuple, you will have two elements, where the first element will be the key, second element will be the corresponding value. So intentionally, I first showed you this line number 9. Print emp1 dot items. When you will do, then you will get this dict underscore items object, which will be a list of tuples. And inside each tuple, you will have two elements. First element will be the key, second element is the value. Now coming here, line number 7. Tup is equals to tuple. Then inside the tuple, I'm passing emp1 dot items. So first of all, emp1 dot items will do what? It will give you this dict underscore items object, which is nothing but list of tuples. So this list of tuples, this list of tuples will be typecasted into a tuple only. This list of tuples will be typecasted into a tuple only, thanks to this tuple method. And the entire result is stored in this variable tup. So print, when you do this print tup comma type tup id of tup, you will get a tuple only. You see, overall you have this tuple, opening first bracket and then closing first bracket. So overall a tuple, and inside this tuple the values have to be separated from each other by commas. So list of tuples will be now converted into a tuple thanks to the tuple method. And here you have those tuples, sets of tuples you will get. These are the sets of tuples. These are the sets of tuples which are separated from each other by comma. So first of all, emp1 dot items, it will return you the dict underscore items object, which will be a list of tuples. Then you pass it to the tuple method. You pass it, that is emp1 dot items. It will return you the dict underscore items object, which will be a list of tuples. And then you pass it inside the tuple method, which will do typecasting into tuple. So list of tuples will be now converted into tuple of tuples thanks to the tuple method. Okay, so here you see inside the outer tuple you have sets of tuples. So this will be nothing but tuple of tuples. Instead of list of tuples, you get tuple of tuples thanks to the tuple method, because inside that you are passing emp1 dot items, which returns you dict underscore items object, which will be list of items that will be converted into list of tuple. Like inside the tuple method, you passed emp1 dot items. This will return you dict underscore items object, which will be a list of tuples. Then this list of tuples shall be converted into tuple of tuples thanks to this tuple method. Okay. And already we have seen line number 9, print emp1 dot items. We have already seen this. It will give you this dict underscore items object. Now L1 is equals to list. L1 is equals to list amp1 dot items. Already the applicability of list typecasting we have seen in our previous videos. If you have not checked them out, then my request is kindly check them out. So inside the list method, what I'm passing is emp1 dot items. So again, emp1 dot items you can apply over a dictionary, and it will return you what? It will return you dict underscore items object, which will be a list of tuples. So here this emp1 dot items will return a list of tuples. Now you have passed this list of tuples inside the list method. So that means the list of tuples will be now typecasted into a list. So what will you get? You will ultimately get list of tuples only. Okay. Here we passed the list of tuples inside the tuple method. So that will typecast into overall tuple only, and hence we got tuple of tuples. Now here we are passing the list of tuples, that is emp1.items, it will return you list of tuples, and this we are passing inside the list method. And list method, as we know, it typecasts into a list. So we will get list of tuples only. List of tuples only. Here you see list of tuples. When you do the print L1, you get list of tuples. And in each tuple you will have two elements. Like here we got tuple of tuples. In each tuple, in each tuple you will have two elements. The first element will be the key, second element will be the value. Here emp is the key, John is the value. See, this keys to value gets converted into key comma value, emp comma John. Then the next keys to value, emp underscore age is to 32, gets converted into key comma value. That is here emp underscore age comma 32. Then the next emp underscore salary is to 72,000, keys to value gets converted into this key comma value, that is inside the third tuple, emp underscore salary comma 72,000. Keys to value gets converted into key comma value inside a tuple. And then this last place is to Delhi. Keys to value gets converted into key comma value inside a tuple. Inside a tuple. Okay, that is this one. That is, this one. And because we know that this is the opening bracket first one and this is the closing bracket first one. Inside this you have the key comma value, place comma daily. Same in case of list of tuples also. Dict underscore items is not there. You see, when I try to print L1, then here we don't get any dict underscore items, because dict underscore items we get only when we directly print the emp1 dot items. Like here I directly try to print emp1 dot items. Here we get the dict underscore items object, which will be list of tuples. Now, when you typecast this list of tuples into a list, then you will get just the list of tuples only, no dict underscore items. So here you will get list of tuples. You see, opening square bracket, and then at the end we have this closing square bracket, and this will be a list. And inside this list, you have these sets of tuples. So that's why it is known as list of tuples. Inside the list, you have the sets of tuples, and that's why it's known as list of tuples. First tuple, emp, comma John, key, comma value. That is, this keys to value gets converted into key, comma value. This is the first tuple. Then the second tuple. Inside the second tuple, you get emp underscore h, comma 32, key, comma value. You see, this was the second keys to value. Emp underscore h is to 32 gets converted into this key, comma value. Emp underscore h, comma 32. Then emp underscore salary is to 72,000. This will be a third tuple. Emp underscore salary is the key, which becomes the first element of this third tuple, comma 72,000 is the value, which is the second element of this third tuple. In similar way, you can get the fourth tuple also. Inside the fourth tuple, the first element is the key, which is place, and then the second element is the value, which is Delhi. Okay. And again, if you do print emp1 dot items, then you will get your dict underscore items object only, which will be nothing but your list of tuples. Dict underscore items object only you will get, which will be nothing but your list of tuples. Okay. So if you want, you can. I've already run this. Each time you run, memory IDs they change. Okay. Each time you run, memory IDs they change. Now, next is, come on. Next is this set. S1 is equals to 10, 20, 30, 40, 50. And print S1, comma type S1. It will give you this set S1. And we know in case of set values, they are printed randomly. Do not follow any indexing or sequencing. 50, 20, 40, 10, 30. The values only we get in random order. Class is set. Tuple is equals to tuple S1. So here we're trying to typecast. Here we're trying to typecast this set S1 into a tuple. With the help of tuple method, we are trying to typecast this set into a tuple, and the resultant will be stored in this tup variable. So when you do print tup tup comma type of tup, then you get tuple only. The values of the set enclosed inside the first brackets, and the values are separated from each other by comma, and hence it is nothing but your class tuple. Okay. Then next, here similarly, you have a frozen set. F1 is equals to frozen set. Inside the frozen set, I am passing this list 1, 2, 3, 5, 5, 6. Here you see value repetition has happened. That is duplicacy. When you print this frozen set, the duplicate value will be omitted. So print F1, comma type of F1 if you do. Here you get this frozen set. Inside the frozen set, 1, 2, 3, 5, 6. The second 5, there is a duplicate 5 has been eliminated. Class is frozen set. Then next is tup is equals to tuple. Inside the tuple, you pass f1. Inside this tuple method, you pass this f1. Okay, so this frozen set will be now typecasted. This frozen set will be now typecasted into a tuple thanks to the tuple method. So when you print tup comma type of tup, then you get this tuple 1, 2, 3, 5, 6. Okay, just try to run this. Next here you have r1 is equals to range 4. Print r1 comma type r1. If you do, you get what? Range only. You get range 0 comma 4. 0 is the start value, 4 is the stop value. Class is range, but we know that inside this range, internally speaking, what values we will get? 0, 1, 2, 3. Now to access these values, either you can typecast this range into a list and you will get these values enclosed in a list. Otherwise, you can typecast them into a tuple also, so they will be enclosed inside a tuple. So tup is equals to tuple r1. So inside the tuple method, you're passing this range r1. So now you're typecasting this range into a tuple. So when you do this, print tup comma type tup, you will get this tuple consisting of these internal values of the range, that is 0, 1, 2, 3. And to which class it belongs? It belongs to this class tuple. Okay. So if you want, you can just run this. So that's it for this class, my dear friends. And if you've liked this video, you can hit the like, share, and subscribe button and press the bell icon for notifications. So thank you.